presenting Spotted, Quantifying Dermatological Conditions Pixel by Pixel. I'm a research associate in the section of dermatology at CHOP, the Children's Hospital of Philadelphia. And my team also includes 2 clinicians in the section, the head of dermatology and the director of research, as well as 2 computer vision scientists as external collaborators. We are focusing on acne because it's one of the most common dermatological conditions today and also one of the most mismanaged, most challenging to manage by pediatricians. There are 70,000 treatment combinations and there's no universally accepted severity scale. So patients are often given suboptimal therapy, and that's a lot of frustrated teenagers, but also very long waiting times to see a specialist and a huge burden on the system. Why is acne so challenging? Well, first of all, it's due to the many facets of its appearance. There's a lot of active lesions to consider, but also post-inflammatory ones, in particular scars. But when a doctor diagnoses the skin, they also have to consider the texture, is it red, how have they been picking, and how to treat it, what has been done already, or also external variables like does insurance cover it? So our solution, we created an automated lesion extraction algorithm. We base it on spectral clustering for the image segmentation framework, but instead of relying on edge map, we design new local geometrical features to encode the characteristics of the skin spots. This allows us to extract all the lesions simultaneously in a completely unsupervised way, and then we can divide the lesions into inflammatory, non-inflammatory, and post-inflammatory ones. To go from the lesions to a severity that they can actually use to guide therapy, we work with the clinicians, and via pattern analysis, we're mapping the visual acne cues to a severity that actually is in direct correspondence with treatments used in the dermatology clinic. The performance of the algorithm is, for the lesion extraction, we obtain precision and recall above 90%. And for some context, when they do studies for lesion counting, dermatologists and clinicians that have been trained to properly count, they range between 85 and 90%, but in general, clinicians have a much higher intervariability rate. So accuracy is more like 75%. We validated the scale with 6 clinicians, and again, our error was below 1 severity level score. And for some context, clinicians, we gave them the same images to rate over time in different contexts, and their error was actually higher, more closer to 1. So we already have a prototype app for the acne that we're testing in the clinic, but this is just one of the many dermatological conditions our system can be extended to, from contact dermatitis, psoriasis, and even wounds and burns. And in particular, we already have another app that we're using for quantifying alopecia areata in the clinic. That's hair loss. And we're hoping that acne is just the beginning of our computational dermatology platform. Thank you very much.
Great job. Who's going to kick it off with questions? Ira, and then Adrien.
Ira, this is so cool. A question, so can you also, based on the analysis, recommend different treatments, or have you looked into that?
Definitely. First of all, the severity scale is meant to output a severity that is in correspondence with treatment intensity, but the idea of the algorithm was also to combine that this would just be the input to a treatment algorithm that Dr. Jan is actually developing, so we wanted to combine it in a much larger system.
All right, Adrien.
Adrien Treuille, Carnegie Mellon. So is the intention for this to be used by a doctor?
Initially, it was meant for pediatricians so we could help them recommend therapy, but we also thought of how patients can use it basically as a teledermatology app, so patients at home could actually, so the system itself here is just a computer vision part, they could actually use it like that at home. But if you combine also the treatment algorithms, they could, for example, use it that they take the picture at home, and a doctor remotely can recommend it, just click yes or no instead of going to the doctor, having a visit, and everything that entails. So basically, it would bring CHOP dermatology clinic, the treatment level at home. So it's to be used by both.
And Erik, there's a mic to your left.
Hello, Jan Erik. Yeah, this is very cool. What are the requirements for taking pictures? Do you need any specific instructions or?
No jumping, kids. But aside from that, we try to make it very robust. The segmentation algorithm works on images that are very fuzzy. That's why we don't rely on edge maps. And so as long as it's within, we haven't tested the full spectrum of what it can do, but as long as it's a reasonable distance and just focused on the skin, for example, when you do it on the cheeks, it tends to work most of the time.
Okay, great.
Another question, anybody else? Yes, Clement.
Is that something you think could be run on an iPhone?
I can't hear you.
Is that something you think could be run on an iPhone? Like
On an
Well,
iPhone?
The app we actually have are all based on iPhones because Chop is running with that. So
Right.
we have a system that's actually integrated with the server at Chop, and we just the doctors take the image from the iPhones basically.
Cool. Any one last question? Anybody? Thank you very much. Great job.